Hey, I'm going to put this up on the screen to get it started out. Big reminder. This is it. This is that one time a year. My son-in-law gets so excited this time of year. I'm gonna go to Google right here and search Fat Bear Week because it's Fat Bear Week. We're about to finish of it. So let's see the voting. If I go to the voting tab, I'll open that in the new screen. It doesn't start till 11 o'clock our time because this isn't out in Alaska. So they don't start till 9 a.m. Alaska time. But let's see who's in today. It's slow loading. We're down to the finals. There's just like 2 days of voting left. So today, Chunk versus 901. So the voting will begin at 11 a.m. our time. There's Chunk on the left. He got really big this year. I think he's got a chance to win this Fat Bear thing. He's never won. But got him versus 901 this morning. And then the second poll, we got Grazier versus Holly. So there's our final Fat Bears. And the winners tomorrow will face off for the championship. There's the bracket right there. Everyone's been eliminated except for just these 4 bears. So 11 a.m., just Google Fat Bear Week. You can see the vote tab right there. You have the other tab that takes you to the national park where the thing is hosted. There's last year's winner, 747. He got eliminated this year, though. He got beat last week. But when you go back down here to meet the bears of Fat Bear Week, it's great. You can go down like Chunk. I like look at the Chunk. See, there was Chunk back when he came out of hibernation in the spring, and there's how big he is here going into hibernation this year. Chunk got really big. So you can sit there and see all the bears. A lot of these bears have been eliminated though, so there's not a whole lot of them. There's only 4 left, but it's great. You can go see what they look like in the spring, what they look like now. So, but yeah, vote Chunk. Oh, there you go. I think this could be Chunk's year. He's a big boy. All right, Fat Bear Week. Fat Bear Week. All right, let's look at actually programming here since we're here for programming. Oh, by the way, let me before we get too far into this, next week's kind of weird because fall breaks this week, right? This is a 4-day week when there's no classes on Friday held at all, and next Monday there's no classes. So we will not meet next Monday because nobody's meeting. I won't give you an assignment until Tuesday because Monday there's no school. But that means next week, we don't have even an A or a B this week because we don't have a Friday, so you can just ignore that. But next week, A day is on Friday. But Wednesday next week is when we would normally, since we're not meeting Monday, would normally meet on Wednesday. Wednesday is the PSAT for juniors, work keys for seniors, community service hours for freshmen. We're not having classes on Wednesday. So next week, A day is the only day we have classes. So I probably won't hold class. I may post a video or something next week, but I'm still trying to decide exactly what I want to do with next week because next week we have a program to write and it's a little more complicated. It's math. We got to get into writing a math program next week. So I may end up pushing that off to the week after. We may do something different next week. I haven't decided quite yet, but just know that next week's just weird. No, there's no Monday. A day is gone on Wednesday because of the PSAT, and then Fridays are only A day. But who wants to start the week on a Friday? I'll make that decision and email you. So watch for that email. But next week's just kind of weird. Just has all fell together. So all right, but let's look at this week. We do not have a program to write this week. This week we are just doing a regular assignment. But what we're learning this week is going to really play into our program next week. So let's go to our grade screen to see what things look like. All right, so 2.01 was due yesterday, October 8th. We're getting numeric input. This is going to play big into our program. So make sure you are paying attention. You're going through the examples, that you know what's going on, and that you can do well in the assignment. So you'll be able to do this for our program. 2.02 this week. All right, here's our lesson. All right, what's in a name? That's what Shakespeare once asked, right? What's in a name? The literal answer is letters. There's letters strung together in a name. That's what's there. Great question, Will. But there are lots of other equally significant questions, like how many Oreos are left over, or what's my age in dog years. That's just as significant, right? You can write a Python program to calculate and answer all your burning questions. The key is just knowing which data type. So we're going to learn about integers, floating point, and string values. Understand how computers store different data types. We're going to use the integer and float functions and the input function in this week's lesson. So float, int, or str means a float value, an integer value, or a string value. As you know, there is a difference between these three data types. So let's see for ourselves. str, string, hello world, right? A value composed of letters or numbers that are not meant to perform a math function. So you can have numbers in a string value, like a phone number. Like a phone number is considered a string value because we're not going to calculate it. What's 3 times your phone number? No, we don't do that. You know, your address has a number in it, but it's not used to calculate anything. So that is considered a string value, even though it has numbers. All right, please enter your first name. Your name would be a string value, right? So the memory space just kind of depends, right? How long of a string is it? The amount of memory a string takes up depends on the length of the string. Of course, the longer, the more memory it takes up. So then there's floating values, right? A floating point is a numeric value that's either positive or negative that contains a decimal point when we need to get more accurate, like 0.01, negative 1.3, 0.0, baby. We need to know that precision. It's not just zero, it's actually zero. We didn't round down. The value of pi, that's definitely a floating point value. Takes a lot of memory space because they have decimals. They're more precise and they end up taking more memory. And then our other value we're looking at, integer values, right? That's a whole number. Could be positive or negative, but it's a whole negative 2, 88, 0, right? The number of cookies you just ate. That might be a lot of memory for the number of cookies, but generally it's low memory space because it doesn't have to have all those decimals. Right. Relatively simple numbers, unless it's the number of cookies you ate. Maybe that's a more complicated number. When writing programs, you got to keep in mind what type of data you're using. If you're looking at a value, is it going to be a floating point value or an integer value or a string? So there's a flow chart you can use. Will I do math with this value? If you're not going to do math with it, it's a string. Treat it as such. If you are, then does it contain a decimal point? If it does, it's a float. If it doesn't contain a decimal, it's an integer. So lots of values seem like numbers, but they're not floating point or integers, like your phone number, driver's license number, all those type of things. So here's a little quiz for us. So let me, I'm going to put the chat on to give you guys a chance to answer this. Let's start the results on a stopwatch. Where we're going to put that? Is that an integer, a float, or a string? Results on a stopwatch. Sid's right on that. He says it's a float. Absolutely. A stopwatch is definitely going to have decimals. It's not just integer numbers. It's very precise. How about the number 8? Generally, it's probably going to be an integer unless for some reason we're doing it for a string, but it's definitely an integer. There's no decimal points in there. Hello, world. Back at that first program we wrote, hello, world. Hello, world, definitely a string. Good job, guys. A social security number. Number. Is that an integer, a float, or a string? Oh, you guys are good. You're on top of that. That's a string because we're not going to use any calculations with that. The number of steps I walked today, which right now is pretty low. The number of steps is definitely an integer. I did not walk 1,000.24 steps today. It's going to be an integer value. The cost of an ice cream cone. Yeah, that's going to have a decimal in there because it's usually $1.99 instead of $2 because they want to sound cheaper, right? 8.342. Yeah, we know that one. That's definitely a decimal. The number of liters in a gallon. Oh, this may be tricky. The number of liters in a gallon. Hmm. All right, you guys are on it. I see a lot of people saying float. Yeah, it's not gonna be an even number. It's gonna be a decimal. It's not gonna be an integer. Yep, yep. And that was something we'd probably have to calculate. So we know it'd be something we'd be calculating. Total books in the Harry Potter series. Yeah, it's not going to be 6.8 books. It's going to be an integer value. The points our basketball team scored, or we haven't quite started basketball season, maybe football season right now, but that's going to be an integer. In sports, we don't score a portion of a point. It's always an entire point. P. Sherman, 42 Wallaby Way. It's obviously an address, right? Finding Dory. That is a string value. And your telephone number, similar to a social security number, that is a string. So let's see. Nice job. We successfully identified. Good job, everyone. Yeah, you just have to know when you put these values in, what are you going to use them for? So very good. You guys are on top of this. All right. When to integer and when to float. Let's say you got a part-time job. So you're working a few hours every week. You make $9 an hour. Well, Python could write a nice little program for you to figure out how much you make each week. That's where the input function could be really useful. Input, right? Write some code that prompts you to input your hours. How many hours did you work this week? You could enter that. Python can calculate that. But you have to tell Python the data type. So by default, this is important to understand. By default, Python assumes, and we know what a problem assuming makes, it assumes that every time you use the input, you're making it a string value. It's just going to assume that. Unless you tell it differently, it just assumes, oh, they're inputting some kind of string. What's your name? What's your favorite animal? Whatever it is, it's a string value. And that's pretty useful. But if you're going to do math, you have to tell Python, this one is not a string. Right? Tell Python what it's working with. Is it an integer or a float? If you know you're going to do math, you got to put the int or the float functions in your code to indicate. So let's see how that works. Let's look at this example below. Job 1, hours equal input enter hours. So Jenny worked from noon to 6. So her boss told her to enter 6 hours on her timesheet. And so she's going to use that to calculate. So here's a variable called rate, and rate is set to the value of 9.00. She makes exactly $9 an hour. So calculating the pay is hours times the rate. So she entered 6 hours when she ran the program, $9, and it wants us to print the pay. So there's where she entered 6. So let's click the next tab. It says error, cannot multiply sequence by a non-integer of type float on line 3. So line 3 caused an error because it tried to multiply the 6 that she entered times the $9 rate, and it got an error because it assumed this is a string value. When she entered that 6, it's treated like a string. Rate, it's obviously treated like a float because you put a decimal in it. So she goes back and corrects her code and puts int in front of the input and then puts it in parentheses, int parentheses, input enter hours. Now Python knows, oh, this is an integer value that's being entered with this input statement. And it correctly calculates 54.0. Notice it puts the 0.0 because it is dealing with a float value. So it's going to give you a float answer. It's also dealing with an integer, but when there's an integer and a float, it's going to default to the float because there's a good chance you may have a decimal answer if you have a decimal calculation, 54.0. So Sheldon worked from noon to 6:15. So his boss said, all right, that's 6.25 hours, 6.25. So that's what he input. So he used the same program and entered 6.25, and he got an error. Invalid literal for int when you put 6.25, because 6.25 is not an integer. So the program needs to be updated. So change that int to float, with the parentheses. Now, when you enter 6.25, it calculates 56.25. It's able to do that because now it knows that both of those are float values. If you're not sure if they're going to enter an integer and a float, then you would want to default to the float. That way it'll handle either one. You could enter an integer, you could put 6 in there, and it would just treat it as 6.0 as a float. That's not a problem. But if you know it's going to be an integer, you can just call it an integer. But if you're not sure, default to the float. So let's look at this fourth page. All right, so Janie and Sheldon both use special Python functions to convert the time to integers and floating point values. So let's select the parts of this code to see how it works. Age is the variable. There's supposed to be an equal sign. It's really small and tight together. It looks like a minus, but that's an equal sign. Integer, this is the function that tells Python to treat it like an integer. Input, what year were you born? That's what's going to pop up on the screen. And when generally, what year you were born, that's going to be an integer, right? You're not going to enter, I was born in 1999.4. No, you weren't born in 1999.4. Yeah, you're going to enter a year. I was born in 2006, right? So that's going to be an integer when you enter a year. But if you said, what is your GPA? That's your calculated grade point average. The majority of the time, that is not an integer. You may have a 4.0 or a 3.0 or whatever that is, but the bigger chance you have like a 3.88. So you want to default to the float. All right, let's look at their guided activity. Here's the program. It says read the code, predict the output, and then run it. And test your program with the input of 3. So when we run it, they want us to put a 3 in for the input. All right, let's check their program. Hashtag numeric input. Here's their main function defined. And they're putting comments throughout the program, which can help. The bigger your program gets, you could put a comment anywhere in Python just to let it know, okay, this part is the input. This part is where we're calculating the total. Python ignores that. Every time you put this little hashtag out front, it's going to ignore that. So you can put comments. See, this is where I'm going to print things all the way through there. All right, input. So number of pizzas, num pizzas, there's a variable name. And here's the input statement. How many pizzas do you want to buy? And then they said the pizzas cost $15.50. So we're going to set that equal to $15.50. So we have two variables. One's called num pizzas. One's called pizza cost. And then we're going to calculate it by multiplying those together. Number of pizzas times the cost of the pizzas. And then we're going to print that. You bought, and then remember, if we have a number, we got to tell it to treat it like a string. You bought this number of pizzas. Each one cost this amount, and your total cost is this. Let's run the program. How many pizzas? We want to buy 3. Error. Uh-oh. Something's wrong with our code. Cannot multiply the sequence of non-integer of type float on line 9. So total cost could not multiply 1550 by our input. Did we miss anything? Why can that not calculate? Anybody have any ideas? We input 3. Should be able to calculate 3 times 1550, right? Oh, Serenity's on top of it. Line 5. Yep, Zachary's got it. We did not tell it anything about the input, so it assumes the input is a string value. If we go in and say, no, this is going to be an integer, so we go put that integer parentheses and add another closing parentheses. Now when we run it and say 3 pizzas, please, it says, okay, you bought 3 pizzas. Each pizza costs 15.5. Your total is 46.5. Good job spotting that, guys. It'll print num pizzas right there, which was the 3 we entered. It'll print the pizza cost right there, which we calculated up here, and your total cost that we calculated on line 9. But just remember, we have to put this string in there when we print these numbers. Without this, that'll create another error. have to put the string so it'll print it because we're already printing strings on that line. If we print it by itself, print total cost, we don't have to tell it it's a string because there's no strings on that line. This is only printing number values. 3. See, it'll print it by itself. But if we want to add a dollar sign out front, parentheses, dollar sign, parentheses, plus total cost. Oh. So we want to print this plus total cost. Now, there's an error because this is a string and this is a float value. So we got to add that string out front of that. So it treats it like a string value. Okay, now we'll do 4650. So remember, anytime you use that number with a string, if we're not sure if we need to use the string, let's use it anyway. Okay, here, I just said string total cost. Even though I don't have a string in there. Is that going to be a problem? No, it's fine. It doesn't care. So if you're not sure, then add the string. But look for that error if it pops up there. All right, now what they want us to do. Read the code, try to predict the output. Num peaches is your integer. Okay, we've added the integer. Pizza cost. Now it says input, what is the cost of a pizza? So we're entering both things. Let's say, because maybe your order, they don't know what sizes you order, so the price may be different. Calculate the total cost, and here's the same print statements. So they want us to test the program 5 pizzas at $19.99. 5 pizzas, $19. We're ordering the big pizzas here. Now this is interesting. Input, we did not tell it what it was, so it assumes it's a string. And it calculated pizza cost times number of pizzas. And this is what it calculated the total cost to be. $19.99.1999.9. They got these over and over and over again. This did not create a syntax error or any kind of error. Python was fine with running this, but there's a logic error, which means it's not an error for Python, but it did not produce what we expected it to. Somewhere we're wrong in our logic somewhere. It's not a Python error, it's a logic error. The output shows the printed cost printed 5 times. This is the cost of a pizza, $19.99. And then it printed again, $19.99. And then it printed again, $19.99. It printed it 5 times, 5 times. So it took 5 times that string value, 5 times $19.99, and it did $19.99 5 times. That's a logic error. Interesting. So we've got to fix that by going up and saying, okay, when we enter the cost, that's going to be a float value. It's not going to be a string. It's going to be an actual, oh, there we go. It's an actual number, but it's a decimal number. So now when we do that, we say 5 pizzas at $19.99. Oh, now it calculates it correctly. $99.95. 5 pizzas at almost $20 each. $99.95. So different kind of error there. But again, fixed by using integer and float. Let's look at the last one. All right, let's try adding a $5.50 coupon. Pizza is really big on coupons, right? So you usually find a coupon for every pizza place. So it wants us to add code that asks the user for the value of the coupon and then calculate the new cost. And in the output, include the value of the coupon. All right, so they want us to use 3 for the number of pizzas, $8.99 for the cost, and $5.50 for the coupon value. So we need an input statement to enter the value of the coupon. So let's enter this, and we'll just call it coupon. That's fine. That's a nice variable that we understand exactly what it is. Equals. So is the coupon going to be an integer, a float, or a string? We're going to enter $5.50. Is that going to be an integer, a float, or a string? What do you think, guys? Do we need integer, float, or string? Zachary says put a float in there. Oh, Serenity's wrote the whole line for us. All right. Coupon equals float, parentheses, input, parentheses. Now let's just say how much is your coupon worth? How about that? Ooh. You can say it however you want to. Serenity had a good one. What's the cost of the coupon? How much a coupon worth? What's the value of your coupon? You can phrase it however you want, as long as it makes sense, right? So I'll just say how much your coupon worth. So now we're going to go ahead and calculate. Right now we're calculating the pizzas times the number, the cost of each pizza times the number. So after that, we can just say minus coupon, right? We can put spaces there just to make it easier to read. Minus the coupon. So it'll calculate the total cost. And at the end, after the parentheses, we'll subtract the coupon. If we put it inside there, it could cause some problems because this needs to calculate first. So let's put it in parentheses just so we know it will calculate first and then subtract the coupon. And in the output, include the value of the coupon. So let's put it, let's see, you bought this number of pizzas. Oh, here they already have it. The coupon is, they've already added that in the output. And they used the same variable we did, coupon. So we did good. We chose the right variable name. The coupon is dollars, and then they put the string because we're printing it with strings, coupon. So let's run it and see if it works now. Well, see if we made any errors that we need to fix. Run program. Oh, let's see what they supposed to be. Run program. Bad input on line 11. Oh, what did we do wrong on 11? Let me take this off. If it did it run okay without that. Run program. Nope. It had a problem already before we put minus coupon. So let's see. Pizza cost, that's the right variable name. It's spelled the same. Num pizzas, integer float, total cost. Bad input.
Mr. Brock, you forgot a parenthesis on line 8.
Line 8. There you go. So even though it gave us an error on 11, it may not be line 11 that's the problem. Yep, we have 2 opening parentheses, and there was only 1 closing parentheses. Let's see if that fixed the problem. Let's go ahead and put well, let's try it without the coupon first. Okay, now it's going to run. 3, $8.99. How much a coupon? $5.50. Now it didn't calculate the coupon because we left it off there, but it runs now. Minus coupon. Let's try that. Okay, so it says 3 pizzas, $8.99 each, $5.50 coupon, but it did not calculate the discount for the coupon because we did not have that in there. Because we were just testing. When you're testing, sometimes you want to remove some things to see does it work without that. So I know, did I mess this up or was there already a problem? All right, 3 pizzas, $8.99, $5.50. Now it took the $5.50 off there. $21.47. All right, good job. Good eye there. Good eye there. All right. Yep. So errors are not always on the line it tells you, but you know it's going to be before that line, right? When it says there's line 11, it shouldn't be a problem down here because it had trouble by the time it got to here. So, all right. That's slide 3 of 3. That's it. And then this just says, do your assignment. Book a lesson, practice, which you can practice back on what we were doing just right where we were at. Let's look at the assignment for this week. All right. When asking the user for input of a numeric value without a decimal, which one of these do we want to use? Which function converts a string to a numeric value with a decimal? Which one of these do we use? Here's some code to calculate the user's age in 20 years. There's an error. Which additional function needs to be used in this because there's an error? The error in here. This is calculating the weight of an item with 2-pound packaging. And then because floating points have decimals, they're more precise and take up more memory. Is that true? Or is that false? 5 questions, pretty simple. If you want to look at next week, we're getting more into the math, and this is called the math module. Again, it may be the week after next. I got to make that decision because I think we need to go over this together, and I don't want to go over it on Friday and have it due Sunday because this is going to be a little more complicated than our last programs. But nothing you can't handle because you guys got this. Most everyone is doing very well in here. This class has my highest average over my math classes, but of course, math is a whole different subject. But you guys are doing very well. Very, very few people have to be here on a Wednesday. So if you get your grade over 70 by Wednesday, and there's not many of you that's below 70, then you don't have to be here on Wednesday. But simple assignment, 5 questions this week. It's all about we're learning about the math portion of Python. Math's a very important part of all programs because generally most programs calculate stuff. Go figure. All right. Don't forget Fat Bear Week at 11 o'clock. And I'll email you about next week. I'm sorry, when I make that decision, what we're doing next week. So have a great day, guys.